Hello, my name is Kang from UMass Amherst, and I'm presenting CensorLess cost-efficient censorship circumvention through serverless cloud functions. To our knowledge, CensorLess is the first censorship circumvention tool entirely built upon the serverless cloud functions. So this is a quick background. So to circumvent the censorship, the many censorship-resistant tools route the client's traffic to the proxy located in the cloud networks. And many so I'm sorry, cloud networks in the proxy servers in the cloud networks routes the traffic to the cloud network, and the cloud provider charge for every byte that flows through it. So these costs as of fast at scale. So the cost is one of the top factors that shapes this whole entire ecosystems. So for the VPN providers, so one of the famous VPN service, Tor, spends $11,000 only for third-party CDN fees in 2018. So, and this number is keep increasing. On the user side, the surveys consistently rank costs among the top 3 factors that people weigh when decide the VPN services. So these two are different sides of the same problem. It's called VPN providers needs an affordable infrastructure, and the users needs an affordable tools. So this motivates our objective: build a censorship circumvention proxy that maximizes cost savings without additional overhead. And serverless cloud functions enables our objective. And what is the serverless function? Serverless cloud function is a modern cloud architecture that reduce the burden of resource management from developers. And when developers upload the program script that consists of functions to the cloud platform, the cloud providers provision, scale, and maintains instead of the developers. And these cloud serverless functions architecture nature generates the key distinctive properties, which is request-based billing instead of the hourly billing, and ephemeral IP addresses, storage and containers, and also it has elastic scalability with high concurrency. And CensorLess fully utilize these key characteristics. Here's the quick summary of what we built. CensorLess is a censorship circumvention proxy deployed on the serverless platform. And we implemented CensorLess on top of the AWS Lambda. And we also compared the Spot proxy, which is the least cost censorship circumvention tool that use Spot instances to save the operational cost. We saved the cost by 97%. And however, the CensorLess vanilla throw away the privacy and anonymity for the maximum cost saving. So we additionally support the private mode trading off with the cost. However, this private mode still saves 63% of the cost saving compared to the Spot proxy's least cost configurations. However, the building serverless functions as a proxy is not simple as any other cloud censorship circumvention tool built on the infrastructure as a service cloud products, because network visibility in the serverless function is restricted at the application layer. Usually, serverless function is invoked by URL addresses, and DNS server resolves the serverless URL address with the cloud provider's public IP address. And the cloud provider server internally map the public IP address, internally map the private IP address with the serverless URL. And this whole process is under the cloud provider's control, so the users cannot see the transport or IP layer. And this disables the socket communication, which make the using serverless function as a proxy genuinely difficult. So our solution is building HTTP-based circumvention proxy that only use HTTPS simple get and post method by intercepting the user's traffic. So here is the simple workflow of CensorLess. So in the clients in the sensor region routes the traffic to the Serverless bridge in uncensored region as any other one-hop VPN services. So as Serverless bridge use ephemeral IP address, container, and storage, the censorship resistance property comes for free. However, the Serverless bridge still fixed. So the operator periodically rotates the Serverless bridge from the current one to the next bridge by informing the next bridge's URL to the current one to avoid the direct communication between the clients and the operator. So the clients redirect the following request to the next Serverless bridge. And as you can see, Serverless bridge is sit in the middle, so it can see every raw content from the clients. So we additionally adopt the VPS server to provide the privacy and anonymity. So first, clients and VPS exchange the public key and establish the encrypted channel at the bootstrap stage managed by the operator. And clients initiate the source communication by sending source message embedded to the HTTPS request. So the HTTPS request is sent by client to the Serverless bridge, and Serverless bridge parse the source message, which is the HTTPS payload, and send the source message to the real destination. So let's see the architecture in detail. So CensorLess consists of 4 different components: controller, function refresher, local proxy, and Serverless function pool. First, let's say the clients want to access Facebook, and the translator in the local proxy intercepts the client's traffic and modifies to the HTTPS GET or POST method to avoid the socket communication. Meanwhile, function refresher clock periodically triggers function refresher and controller, and the function refresher generates the new Serverless bridge and retire the old one. And the controller periodically rotates the Serverless bridge by taking the next Serverless bridge URL to the current one. So let's say the purple one is the next bridge, and this purple's URL address is tagged to the blue's to the Serverless bridge, that blue color, and migration information fetcher from the local proxy fetch the next Serverless URL, which is the purple one from the blue one. And the following request is sent to the blue Serverless bridge, and this whole migration process is seamless. So in a private mode, we use the same components, control these 4 components, and we only adopt the VPS server, but yeah, all process is same, but use source communications. One interesting finding is that we discovered that AWS Lambda network allows domain fronting. It's well known that the AWS doesn't allow anymore. So the local proxy can send the HTTPS request over fabricated subdomain, and which can support additional censorship resistance. So we evaluated our CensorLess performance, and we measured the throughput across 3 different applications. First, browsing CNN.com with heavy objects, downloading PDF files, and watching short stream video. While the burst timing and total durations are different, depends on migration, the total overall throughput with proxy and without proxies are almost same. And we also evaluated the operational cost, which stands CensorLess out. So, and we compared with the 2 least cost censorship circumvention tool, which is spot proxy and mass browser. With the spot proxy's least cost and optimal scenario that use the optimal and least cost spot instances always, we CensorLess reduced cost by at most 97% with request-based pay-as-you-go pricing model. And with the CensorLess private mode that has extra cost because of the VPS server, still reduce 63% of cost. And when the number of processes increased to 300, then it still CensorLess stays under the $3.5. We also evaluated the circumvention effectiveness both in simulations and in real-world sensor vision, Nanjing, China. In the simulator, we used game theory censorship simulator, assuming that 50% of the clients are censoring agents with the capable of discovering and blocking proxies. So CensorLess achieves about 95% user connectivity and non-blocked proxy. So also we deployed the CensorLess on the Alibaba cloud in Nanjing, China, and we tested accessibility to the blocked domain list, a well-known blocked domain list in mainland in China. We tested with 500 domains, and CensorLess bypass censorship without being blocked. But in the private mode, CensorLess fails just for one case, which that website simply doesn't allow any HTTPS request, which is not related to our system. So thank you, and Artifacts is available on Bitbucket. And if you have any question or if you want to chat about these projects, feel free to just chat me.
Thank you.